Hello and welcome to another daily Leetcode challenge. Let's begin question 228, summary ranges. You're given a sorted unique integer array nums. A range AB is set of all integers from A to B inclusive. Okay, one more time. A range AB is the set of all integers from A to B inclusive. Return the smallest sorted list of ranges that cover all the numbers in the array exactly. That is, each element of nums is covered by exactly one of the ranges, and there is no integer x such as x is in one of the ranges but not in nums. I think I understand. We're given a sorted unique array, a sorted unique array of integers, and we're supposed to essentially summarize that list into what it would be. Summarize that list as a set of ranges. So, for example, um, if we were to given an array 0, 1, 2, 4, 5, 7, then the set of ranges that could be set are 0, 2, because these 0, 1, 2 are consecutive, 4, 5, and finally 7. 2 and 4 have 1 between them, and 5 and 7 have also 1 between them. So a summary of this nums would be, I see, I see. Okay. Um, any other examples? Um, 0, 2, 3, 4. So 0 is supposed to be alone. 2, 3, 4 is together. 2, 4. 6 is alone. 8, 9 together. And okay. So these sorts of questions should probably be approached almost like a state machine. There's it seems like there's a lot of moving parts, but at the end of the day, what you're really just doing is um, keeping track of a couple of well, first of all, going through the array once, but also as you're going through, keeping track of the of some variables that you introduce. And let's start by introducing something called a start and something called an end. A start and an end will, as we're iterating through the array, represent the first and the second number in the output. Obviously, also let's have an out, be an empty list. And now for n in, or let's iterate over the indexes of these nums because we will actually have to be looking ahead at some point. So for I in range len nums, we're going to have a current be equal to nums I, and the next be equal to let's see, -1 if. So this is the next. Yeah, next. -1 if um, if I is less, no, one more time. Nums I plus 1 if I is less than len nums minus 1, else -1. So in the case that we're looking at um, in the case that we are looking at the second, at the last index in the array, give us -1. Last index in the array. So wouldn't this also be okay if I just do if I is equal to this? This might be more nums I plus 1. I think I like this more because this clearly indicates that we're looking at the last element in the array, and if we're looking at the last element, the next is going to be -1. Else, give us the next number. That's it. At this point, let's start updating things that we care about. So, um, what do we care about? Which two values did we introduce to sort of emulate a state machine? Let's see. If start is none, then let's just set start to current, right? Um, this would work in the instance where we first encounter an integer, the first index in the array, and potentially other times when we drop start and end to essentially emulate us writing to output. So if start is none, then start is equal to current, but now what? Now we need to check the time where we would write a next, sorry, an end. An end we would write if current plus 1 does not equal to next, then end is going to be equal to current. And that's it. At this point, we already found two conditions. One at which point we will update start, the other at which point we will update end. Finally, the third condition is if we have both of these, both start and end filled out, then we would actually want to update our out. So if start is not none and end is not none as well, then let's say out append, and let's have a formatted string here that would look something like start end, and of course let's update both start and end to equal none. This should be it. Let's go through this state machine one more time. The two states that we care about are start and end, each being updated as we iterate through our input array nums. We start updating start if it's set to none, which covers the cases where we first start iterating over the input array, as well as times where we've already maybe somewhere down the line, but we have actually just wrote a range to our out file, output, and we have restarted start. And then the next state that we care about is when to write end. And end can be written in two cases. Well, actually, end is always written in one case, if the current element that you're looking at, plus 1, does not equal next. Let's see if this runs. And it does not. Right. What about the case where start and end are the same value? Well, if start and end are the same value, that directly shows us where we would be worrying about that. So if start is equal to end, let's have this out append f formatted string, or just a string of the start. And else, of course, let's have this. And both tests are passing. Let's see if everything passes. And no, not everything passes. And we have negatives. Let's see, was that part of the constraints? Part of the constraints is that we do have negatives. Okay, where did I where did I, oh, I said that nums would be equal to -1. So okay, let's start treating negative numbers as potential values in the array. Instead of setting next to -1 in the case where we have reached the end, let's call next none at that point. And then, let's see, if nxt is none, or, and let's use this test case right here, and run this once again. All three tests pass. We submit our solution once again, and perfect. Okay, so we're not beating a lot of people. Let's see what are some better solutions. Sample 15 millisecond submission, start end result, same approach, while start is smaller than length of nums and end is less than length of nums. Interesting. End plus 1, if end plus 1. Okay, so they have a while loop instead of the for loop that we were doing. And what are they doing inside of this while loop? Well, first of all, the while loop only goes as long as start and end have not exceeded the limits of the array. So at some point, they're going to be updating start and end. If end plus 1 is less than nums, and nums end. Okay, so this condition is checking if current is exactly 1 greater than next. So, and what is this? If n plus, okay, so this is checking if we're in the situation where index, which currently is just end, is not the last element, and our condition for a continuous sequence of integers checks out, then we just append 1 to end. Else, we write, else we else. So in which case would that not work though? We start off with both, with end equaling 0 and start equaling 0. So in the case where this doesn't check out one of these two, either we're looking at the last element or the next sequence, or the next integer is not greater than 1, then if start is equal to end, means that we have 1, then we would simply do this, start, end, end, end. I think I understand it. I don't understand where the increase in speed is coming from, because it seems like they're still iterating over the array. They're just doing it in a more complex situation. Would this be allowed? I want to copy the submission and make sure that it's not significantly faster. Let's restart this. Okay, and just as I thought, this same solution that was beating everyone a while ago seems to lie in the same sort of runtime percentile as what we did. And honestly, this state machine approach, which that one was as well, is much more explicit with regards to what start is, what end is, what current is, and what next are. So I would probably just use this instead. Unless, let's see how we're doing on time. Okay, honestly, this is a good enough solution. I would stick to being more explicit with the naming variables and more explicit with what the conditions are, rather than maybe saving a few seconds milliseconds on the runtime. So with that, let's end for today. Thank you for watching. Please like and subscribe. See you soon.